Welcome to your video lesson for 3.4 for Precalculus. We're going to be talking today about solving rational equations. Just like we looked at last time, rational equations are equations that are put in fraction form. Um, if we were to try to graph it, you'll notice that it looks something similar to this. Now, this right here has two things going on. We have what's called a vertical asymptote, and then we have a horizontal asymptote. The vertical asymptote is where those excluded values come into play because we don't want to divide by 0. And the horizontal asymptote is just what happens if we were to look at the function going to infinity or negative infinity. Where does the graph level off at? So when we're solving it, we're going to actually really focus on what happens with our vertical asymptotes. Now, when we solve equations like these, the biggest thing we always try to do is make sure that we have a common denominator. So you're going to want to find that common denominator by finding the GCF of your equation. Once you do, we're going to actually get rid of the fraction as a whole. We're going to clear it out, and we're going to show you with the next couple of examples. So I'm going to try to keep this video relatively short so you can see and understand just the basis of what we're doing. So on our first example A here, I notice that I have an x plus 4 down below. Underneath the 7, I secretly have a 1, and again, another x plus 4. So my GCF right now is going to be x plus 4. Now, I'm putting it in parentheses right now. Later on, when we have multiple, you're going to want to separate them, so that's why I'm getting in the habit of it. What I'm going to do first is I'm going to state my excluded values, which are the values that I don't want to have set equal to 0. So I don't want the denominator to ever equal 0, so we're going to say, hey, for my excluded values, x cannot equal negative 4. Later on, if we get an answer of x equals negative 4, then the answer doesn't work, and we simply say no solution. So check it out. I'm going to multiply everything by that GCF. I'm going to distribute this x plus 4 here, here, and here. I'm going to show this first step to show you what happens when we do this. Afterwards, later on, when you're like, oh, I already know what happens, I'm going to skip that step. That is totally fine. But make sure you pay attention and you see, hey, what's going on? Or if you're the kind of person that's going to forget each time, just show the step. It's totally okay. You'll notice now that we have the x plus 4 over x plus 4 right here, which simply reduces. Likewise here. Now, this negative 7, I'm going to distribute in. So I'm going to end up with 3 minus 7x minus 28 equals negative 4. And I don't know about you, but this looks like a much nicer thing to solve than the initial equation we started with. So combining like terms, I'm going to have negative 7x, what's that, minus 25 equals negative 4. So then adding 25 to both sides, negative 7x equals 21. Dividing both sides by negative 7, x equals negative 3. Now, normally we would plug it in and say, hey, did I break my equation? But that's where our excluded values come into play. The only excluded value I had was negative 4. And since my answer did not come out to negative 4, guess what? We're done. That's our first one there. So now let me show you what happens when things get a little more complicated, but definitely pause the video here if you need to look back at any of the work, replay anything before you move on. So on letter B, you'll notice again that we have a denominator with several things going on. It's always good advice to factor to make sure you see, hey, what are my terms? So, of course, using your x factor or whatever method you choose, right, you should see that, oh, I should have 6 and negative 2. So the bottom here is going to be composed of x plus 6 times x minus 2, which, coincidentally for us, is also present in the other fractions. So my GCF is going to be a mixture. It's going to be the product of x plus 6 and x minus 2. So when I multiply everything by this GCF, I'm going to give both of those terms to everything. Now, this is the part where I said, okay, if you understand now what's happening, this is kind of where that shortcut comes into play. When I multiply the 3 by this, the x plus 6 cancels, it reduces, so you're left with x minus 2 being multiplied to 3. Likewise, when I multiply this to 1, the x minus 2 reduces, so I'm left with 1 times x plus 6. I'm just showing this as the placeholder, but again, if you see that, you're like, okay. Then on the last fraction, you notice that both of my terms in the GCF get reduced because they are both present there. So I'm just going to say that equals 4. So now we have a nice, multi-step algebra 1 equation. So we're going to get 3x minus 6 after distributing plus x plus 6 equals 4. And at this point now, we are home free to go ahead and solve it. 4x equals 4, x equals 1. Now, I did forget to do something, and I'm sure you probably caught it at this point. We didn't check for excluded values. So my excluded values were whatever made my denominator 0, and I need to check all of my cases in case there's one that's different. In this case, I only have 2 excluded values. X cannot equal 2 or negative 6. And since neither of those numbers are part of our solution, we have a valid answer. So again, make sure to pause the video, take a look back, write down your question if you have one before you move on. I don't want to make this video take too long, but I also want to make sure that I address most of the talking points that I would have if I were in class. Let's talk about what happens when things don't always work out so nicely, and I'll show you what I mean. So I'm going to factor the bottom again. The middle term is factorable. It is our difference of squares. So we're going to have x plus 2 times x minus 2. So you'll notice that our GCF is going to be the product of those two, x plus 2, x minus 2. Let's do our excluded values first. Let's actually remember to take care of that. So my excluded values, x cannot equal positive 2 or negative 2. Neither one of those answers is good for us. So we're going to multiply everything by the GCF. So we're going to multiply everything by x plus 2 times x minus 2. So again, if you recognize the pattern, multiply this here. You'll notice the x plus 2 is reduced, so I'm only left with x minus 2 equals the next term I multiply the GCF to, reduces both of my GCF terms, so I'm going to be left with just the 4. Now be careful here because I do have a minus in between, so I got to make sure I keep that negative with the 1 times, well again, the x minus 2 reduces when we distribute this in, so the only thing left over is the x plus 2. So when you do distribute this, you want to make sure you distribute the negative. X minus 2 equals 4 minus x minus 2. So now we're going to solve that. Very nice and easy. We're going to go ahead and combine like terms. And then I'm going to add x to both sides. So I should get 2x minus 2 equal 2. Add 2 to both sides. You get 2x equals 4. Simplified, you get x equals 2. However, 2 was an excluded value. So since that didn't work, because this was excluded, that means no solution. Now, it is possible that you could get multiple answers as part of the whole solving these, and I'm going to show you one more example that kind of goes more in depth with that. Again, make sure to pause the video if you need to take a look at the work. Write down any questions you may have for me when I get back, and let's move on. Let's take a look at example H. Now we're getting into some juicy territory. So again, we're going to factor. The bottom over here factors into x plus 4. times x minus, or x plus 2. I totally knew what I was doing there. So my excluded values are going to be cannot equal -4 or -2. So we're going to multiply everything by the GCF, which is x plus 4, x plus 2. So when we distribute that in, and let me move that up a bit, we're going to get 2x equals, oh, missed that one. Here, the x plus 4 reduces. I'm going to have x times x plus 2 minus 2 times, well, the x plus 2 reduces, so I'm going to be left with x plus 4. Distribute, and you're going to notice that we end up with some x squared terms. So x squared plus 2x, then what we got here is minus 2x, then again here, we get minus 8. Right? Not the prettiest, but at least some of it cleans up. So I'm going to get 2x equals x squared minus 8. I am going to need to move everything to one side of the equation, which means I'm going to move the 2x over. So then we should have 0 equals x squared minus 2x minus 8. Before you freak out and think, oh my gosh, I've got to use the quadratic formula, you don't necessarily have to. We are going to keep it to factoring for the most part. So these expressions should factor nicely. This one is no exception. We're going to end up with x minus 4 times x plus 2. So in setting up each of these equal to 0, I find that x equals 4 is one of my solutions, and x equals -2 as one of my solutions. So let's compare our answers to our excluded values. So you'll notice that -4 and -2 were the excluded values, and only the -2 popped up. So this one didn't work. This was excluded. This one worked, however, because it was not excluded. The excluded value is -4. So I'm going to box only my x equals 4 answer. So that is the one that works nicely. So take a look at the problem, see if you have any questions, see if you need some time to process it, pause the video. With these types of expressions, we can involve them with word problems. I will actually pause the video now so that you can have the word problems in a separate video. And then that way you can take a brain break, figure out what to do with your life, maybe go on a quick walk, take a selfie, take care of your B-reel, all that fun jazz. So I'll see you in the next video.